2022 electric Mustang Marquis or whatever these things are. They're not a Mustang. So I'm going to post in the Facebook group. I had it in air conditioning mode, and in air conditioning mode it was holding rock steady at 154 psi on the high side. Now I'm about 400 yards right off the Pacific Ocean over here, and it's 55 degrees, 54 degrees right now, and it was holding a really high side pressure compared to other electric compressor cars. As you can see, this compressor is mounted on rubber mounts to keep the vibration down. I have it in heating mode right now, and in this vehicle it's now using the compressor. It's not reversing at the fittings, the pressures, and going in reverse flow like we're used to in a residential system, because we're still, our low side still low, our high side still high. But what I did hook up to, see the heater hoses over there? So it's using the compressor, and it's using the heat of the air to heat glycol, and it's going through a plate heat exchanger. Where's that guy at? Right there. So is this the one, or is this the one for the back? Nope, this is not the one. So it has multiple. There's another plate heat exchanger. Unfortunately, when I came out here, they already put this in, and I'm not going to take it back out. This is dead cold. So this plate heat exchanger and this reserve is super cold. This one's lukewarm, but the lines are hot. Now you see my temperature probe right there on that metal line right there, and I'm on the metal line right here going into a heater core, and you see 109 degrees and 74 degrees. So this is my heated water that's coming from the AC compressor from the hot discharge, is going to another plate heat exchanger somewhere here where we can't see right now. It's heating up the glycol, then an electric pump is pumping it up and pumping it over to, it's on my suction line. So this one right here, this is the source. The source water is right there at 110 degrees, and it gives off its heat into the cabin, and it's coming back at 74 degrees right here. So that's the heat loop right there. Now under the heating mode, and as you see, I don't have all my sensors are somewhere else, all my stick-in sensors that you always see me use. So I grabbed another set of gauges. We got 117 degrees coming out right there because we are in defrost mode. I have it in max defrost right now. I wonder if I could take the AC off, see what it does outside. It's gonna keep, it should keep it on if it's okay. It says here that I've turned off the AC. Let's go look out there and see if anything has happened. I should have just brought in my pad with me and we could read it. It's still on, it hasn't changed anything. So of course defrost always wants the AC on, and you could actually see all the water developing. Let's see if I could zoom in there. Right there, that big metal line with all the water drops on it, because we're a little foggy out. There's a little humidity in the air. Let's go play around up here. So this one is not doing reverse refrigerant flow like some of them do. This one is relying on just flowing the hot discharge gas of the compressor into a plate heat exchanger. So some flow the hot discharge gas into the plate heat exchanger, and other ones will reverse flow of the gas of the compressor and actually make the evaporator a heater and the condenser basically the evaporator. It'll get cool outside. So let's look at this right now. There's our pressures outside. I have it on max high temperature right now. And on some other vehicles, you'll see the high side and low side flip. The ones that actually switch the gas flow to the evaporator, you'll see them flip, and then this would become like 120 or 140 psi, and this one will become 30 or 20 psi on this side. It all depends on year, make, model, vehicle, the manufacturer. This is the Wild West. It's a complete mess out there in the way they're handling heat pumps in the automotive industry. There is no really nice standards like usually the residential. There are some funny things in the residential. There are 2 expansion valve systems out in the condenser. There's some that put one indoors and one outdoors. There is a few different ways, but automotive is really messed up. Our temperature right now, 114 degrees, is being delivered of hot water to the heater core. 75 exiting. We got 118 degrees, so there's a little bit of discrepancy there. And at first, before the hot water was heated up, I was wondering, I don't know about these Mustangs because I haven't read about them. I don't know if they have a PT heater that gives instant heat, because when I thought I was getting like 90 degrees being fed to the heater core, I was getting 110 degrees out of the dash up here, and I go, that's too much of a discrepancy. I wonder if there's some instant backup heat by a PT chart. But one of you guys out there probably read about these things, or into Mustangs and electric Mustangs, so you probably know that there's an electric heater or there's not an electric heater to give the instant heat before the heat pump has a time to heat the glycol to get the customer rapid heat. All right, see you guys later. I hope to be able to get one of the other vehicles, if I have time, that actually switch the high side and low side, so the low side becomes high pressure and the high side becomes low pressure. I think I've put up 1 or 2 videos on that before, but let's see if anytime recently I come across another one. See you guys later.